PFAS are these compounds that are pretty new. You know them from Teflon pans, from your Gore-Tex rain jacket, from any non-stick, like waterproof coatings. Typically have some component of PFAS, even like some dental floss and other things like that. And so it's a widespread molecule used in a lot of things, but there's these issues with it.
So generally our lab focuses on contaminant transport and specifically looking at contaminants in subsurface environments, so aquifer systems, soils, and groundwater. So a lot of aquifer systems are drinking water supplies. And as we're finding more and more of these chemicals contaminating these supplies, it's important for us to understand how they transport through these systems so we can better mitigate risk and figure out remedial activities. And so I'm looking at the physical mechanisms within soils and groundwater to study what sort of conditions impact their transport and to what extent those conditions will impact transport.
PFAS it's a really fascinating compound. It's a totally man-made synthetic compound, and that's the issue with it, is our bodies have no way to break it down, and so it tends to what's called bioaccumulate. So even a tiny bit of PFAS over an extended period of time can lead to a lot of issues.
In the environment, they stick around for a long time. There have been a lot of cases of these chemicals being found in really remote regions where they clearly weren't used, so remote Arctic regions, for example. And they have also been linked to a lot of human health issues. So basically what this is saying is where they're being introduced into the environment and the conditions there impact how they will move and how readily they'll spread through an aquifer, for example.
The immediate reason for this research is to clean up the water so we can drink it. There's a lot of worry about this buildup of these PFAS chemicals. These very unique properties of the chemical make it a really unique and interesting research problem. And it's just an opportunity to use all this physics and chemistry that I've learned in a way that is making a difference, cleaning it up, and doing some immediate good.